So welcome back guys, this is Madhav PVL, and in this video we are going to discuss about the adversarial search, and we are also going to discuss about the games. So how the games are done with the help of this search algorithms. So basically min-max algorithm is something which is different from this. So min-max algorithm has to examine the number of the gains exponentially in the depth of the tree. So to avoid that, we are just considering this alpha beta pruning. So we will just discuss in the next videos. So what is adversarial search? So in this search we need to consider the plan, like if someone is planning against us. So we need to just think like if someone is working on defeating us. So if they're working on defeating us, then we need to just either escape from them, or either we need to just give some counter attack. So those are the things which we can just do in this type of search. So this is basically done in some of the two-player games like chess. So utility values for each agent are equal and opposite to another player. So it may either be equal or we can just tackle with the other player. So utility values are in this way. So what is search versus game? So what is the main difference? So search is not recommended for this this environment. So this what we can just say like challenging environment. So in this type of challenging environment, search is not recommended, whereas games are is recommended. So the solution is a heuristic method for finding the goal. Here the heuristic value will be given and you will just find the goal. They can find the optimal solution, whereas in the search this can be done only if the path is stable. So if the path is stable, then we can just perform the search operation and we can just find out the optimal solution only when the path is stable path. So evaluation function, estimate of cost from start to goal through a given node. So that is the process which we can do in the search algorithm, whereas in game algorithm the solution is a strategy. So it differs from point to point. The optimality depends upon the opponent. If the opponent step is tough, then we need to just give something tough or either equal to that particular opponent. So the time limit forces an approx solution. So sometime in the chess, even after 2 to 3 moves, the game gets completed if the opponent is too tough. So the time limit forces an approx solution. So evaluation function is goodness of a game position. So according to the opponents and according to the gameplay, the evaluation function will be dependent. So game with 2 players. So what is a game with 2 players? So we can just consider those 2 players as min and max. Sorry, max and min. So max moves first and takes turn until the game is over. Winner gets award. So some of the basic elements are S of O, the initial state which specifies how to set up the game. So how to set up the game is defined with the help of this S of O, whereas players, so defines which player has to move, whereas actions, so returns the set of the legal moves. So result SA, so the transition model which defines the result of a move. So terminal test S, so it is true when the game is over and false otherwise. So it will just decide whether the game is over or not. The utility S and P, the utility function defines the final numeric value for a game that ends in a terminal state S for a player P. So a game tree is where nodes are games, here the edges are moves. So here we can just see the min-max algorithm. So I will just discuss it in the next video. So this is all about knowing about the game and the search, the differences. Thank you for watching. Please subscribe to Works After College.